Hello and welcome to Chapter 2. We're going to talk about some sets here. And specifically, we're going to give a little introduction to an area of math called set theory, which is super cool. So I'm going to give a short, super quick introduction to some things that are in set theory. So one of the things that's in set theory, and set theory is really was pioneered by someone named Cantor. So imagine we have this set. All the numbers between 0 and 1. We know how big the set is, right? This has a distance, a length of 1. But now, what happens if we erase the middle third? So if we erase everything, between 1/3 and 2/3, okay, well, we still know how big the set is, right? The set is now 2/3 the size it used to be. Well, let's remove the one middle third of what's remaining. Each piece, we remove the middle third. And again, well, we still have 2/3 of the 2/3 that we still had remaining, and so on. And if you just keep on removing the middle third of what's left, you get essentially a fractal is appearing. And this is a very common thing to talk about in set theory, and my eraser actually doesn't get any smaller, but we're going to keep on trying to get rid of the middle thirds. Yeah, my eraser doesn't get any smaller. And then you get something that's called the Cantor set, which is really exciting, something by Cantor. Another really cool thing about set theory is if you look at all the integers, so like, all the negatives, like this set is exactly the same size as when you get rid of the negatives. Exactly the same size. But if you look at all the real numbers, any real number like 2.11003375, etc., pi, all that stuff, that set is actually a bigger kind of infinity. So there's all sorts of fun things in this notion of set theory that we're not gonna really talk about all those fun things, but it's a really cool area of math. These are some of the things. Again, this is the Cantor set, and this is different kinds of infinity, and sometimes it's a little tricky which ones are the same kinds of infinity and which ones are different kinds of infinity, but all fun things to talk about for set theory. And that's what this chapter is about. It's a small introduction to set theory, hopefully in some very targeted ways to help you as people going into computer science. All right, so it's math material targeted towards computer science. And this is a little snapshot of an area of math that's super fun and is going to be applicable to you. Okay, so one of the things before we really get into the material that I want to drive home here, I've said it a few times, but I want to drive it home. We are talking about mathematical sets. Okay, so there's a lot of different ways of approaching sets. And again, there's a lot of terminology in computer programming and stuff like that relates to sets, and a lot of it's applicable, a lot of it's related, but specifically we're going to focus here on the mathematical idea. Okay, so just keep that in the back of your head with everything that you're learning here. It applies to programming, it applies to other areas of computer science, but we're focusing on the mathematical construction of these things. Sets are a very specific thing in mathematics, and that's what we're going to talk about. So the last thing to talk about before we really get into it, I think I said the other thing was the last thing, but this is the really last thing before we get into it, is I want to make a quick note on how to approach these videos. So I'm going to be, of course, writing down and drawing things. It is very helpful for you to also be taking notes on your own. Maybe you're taking notes on paper, maybe you're taking notes on a tablet or a laptop, but to write something down. You don't need to write exactly what I'm doing, but please write something down. It helps you remember, helps you find things, and it's a good way to be organized and retain information. Secondly, I'm going to be introducing some examples. I'm going to be asking some questions, and I'm going to be just sometimes introducing an idea without giving an example. These are all really good times for you to pause the video. Pause the video, think about it, write something down, answer the question, try to come up with an example. That's how learning happens. Learning is not a passive thing. It's not just watching the video. Okay, you have to pause the video, you have to think about the things, you have to write things down, you have to have monologues. That's one of the pausing and rewinding is an advantage to videos, but the lack of dialogue is a disadvantage to videos, which is why talking with me outside of the videos is also really important. Okay, so please utilize the pause function, think about things, write things down. Another really good thing is to take a red pen and write down a question if something doesn't make sense, or if you're curious about something. And you can highlight that question to ask me later. That's really good as well. Okay, I know you know most of these things, but I wanted to say them. It's the first video. Let's move on. Let's introduce some sets. This first video is going to be longer than most of my videos. I try to keep them a little shorter, but we've got kind of a lot of just introductory stuff to get through right here. So let's just do that. So we're going to start by talking. I know, very surprising. We are going to start by talking about some sets. Okay, and so sets. I'm not going to give really formal definitions for a lot of things in this class. We're going to mostly teach a lot of things by examples. There are more definitions in the textbook, and there are also more definitions that I can point you to if you want really more very precise mathematical stuff. Again, I'm talking about a mathematical idea, but I'm not really teaching a math class. Okay, so keep that in mind. But for those of you who don't know, I am a mathematician. I do have my master's degree in applied math. And so that is, kind of my forte. All right. So sets, again, think of them as collections. And they can be collections of anything. They can be words. I can't spell anything. I think that was really bad. They can be collections of words. They can be collections of numbers. They can be collections of pictures. Anything you want to collect, you can collect in a set. Okay. So we're going to be kind of mostly doing words in this video. But again, a little warning here. Sets are not the same thing as arrays. Okay. There are a lot of similarities between sets and arrays, but they are not the same thing. Okay. So if you're thinking about arrays, take it with a grain of salt. So let's get into some examples of what some sets can look like. So again, sets can be defined with words. So maybe we say, let's maybe have a little example here. That's why I called it an example. And say, let's consider all the video games that I've played. Or all the video games that Jason has played. Okay, so sets can be collections of video games. All right, Jason has played. So we could visualize this. We could visualize this, it could, take a color, let's maybe green, and write some down. I've played. And again, they're not arrays, so they're not necessarily ordered. I've played Stardew Valley. I've played League of Legends. I've played Coral Island. I've played Slay the Spire. I'm just going to write down a bunch of items. A bunch of items that are going to work for us to talk about. What other games have I played? I've played XCOM 2. I've played Star Wars: The Old Republic. I'm going to abbreviate that. That's too much writing. And I could keep on going. I've played a lot of video games. Okay. I've played Super Mario. Let's go a little old school. The original. Anyway, we could go on forever. We could make this video as long as we wanted. But we could make a set out of these video games. And we could define that set with words. And what that would look like is we could say, let S, or you could call it anything, any letter. You could call it, I don't know, a word, just like any variable, right? In computer programming, it doesn't have to be a letter. Mathematicians are just lazy. Let S be the set of my Jason's 3 favorite video games. All right, and we could graphically show that by drawing a little box around them. So my 3 favorite games are Stardew Valley, Slay the Spire, and XCOM 2. So this yellow set is S. So you can see, right, there are 3 things in this set. As I've written it. There are 4 things outside of the set. In reality, there are many more things outside of the set because I've played so many games. But this is one way that we can define a set. This is what it looks like. Okay? We can visualize it like so. The visualization is a helpful tool, but it's not as precise, but it's useful. All right, so maybe that's what S looks like. We could define another set, right? Or let's leave that up, actually. We could define another set, and let's say P. Let P be the set of farming sim games. If anyone knows anyone knows about video games, that you know that Stardew Valley is a farming sim, and so is Coral Island. So we could circle these 2 sets and say that's P. And kind of like a Venn diagram, right? You can see that, okay, some things like Stardew Valley, those are in both sets, P and S. Some are in one set, not the other, right? They can have any combination, and we'll talk about how to relate different sets in future videos, okay? But for now, we're just talking about these are ways of defining sets. You can define sets with words, okay? And notice that these sets, like we didn't actually name any of the games here. We just described them. That's something that's known as intentionally describing sets, not the word intentionally that you're thinking of, though. And we'll talk about that in the next video. All right. So let's talk about some new ways of describing sets. You can use words, but you can also use symbols. Okay, so we could define a third set. Let the set Q, and we use those squiggly brackets to define sets. This is extensionally defining sets, but we haven't introduced that term yet. So we could say, it's a set containing the game League of Legends and the game Star Wars: The Old Republic, which has the abbreviation SWTOR. So that's another way to define a set with symbols. These are the curly braces. A lot of times I'll call them set brackets. All right, that means set. The set of, or just the set. Set of this thing and that thing. And as a reminder, even though it looks like there's an order here, the order doesn't matter, okay? There is no order to sets. So we could also have defined Q as Star Wars: The Old Republic and League of Legends. It's the same thing. And this is where the picture is really useful. Because again, it doesn't matter which comes first. It's just, are you in the yellow set, or are you not in the yellow set? Are you in the blue set, or are you not in the blue set? Okay? There's no order to any of this. All right, and that's going to be very important as we continue talking about some of these things. All right, that's pretty much most of that. All right, one more thing I want to talk about in this chunk of videos. 2 more things, actually. I'm not going to do that same thing again where I say one more. There's really 2 more. Is let's look at some new terminology I want to introduce. Let T be the set of these games that I've never played. Okay, let's write that down. So T is a set of, let's see, which of these games have I never played? Well, I've played all of them. So which of these have I never played? Nothing goes in the set. This is what's known as the empty set. And usually we don't leave that much space, but that's really what's happening. It's set brackets with nothing inside of it. This is called the empty set. Okay? A lot of times it's abbreviated, or like the notation is the Greek letter phi, capital phi. All right. I think it's capital. I think that's capital. It's definitely phi. All right. So that's the empty set. And then another really important set that we talk about is the domain of discourse. And that's omega. So omega is the domain of discourse. And what that means, it's everything. So is all the games in this case. All the games, but in general, right, it's all the things being considered. Or to make things more simple, T, the empty set, is nothing. We don't really abbreviate it T. Phi, the empty set, is nothing. Omega, the domain of discourse, is everything. Okay, so we also have nice things for nothing and everything. Okay, now the actual last thing is a little bit more of notation, and that's the element notation. So for example, we look and say, oh, Stardew Valley was in the blue set. My computer was lagging a little bit there. Stardew Valley is in the blue set P. So what we can write is that Stardew Valley is in the set P. So this is what's known as an element sign, and it means is in. Called the element sign. All right, we can use that for anything, right? So we can also, let's say Coral Island is also in P. And again, I think it's looks like maybe it's just my preview of the recording that looks like it's lagging. Maybe it's fine. But yeah, Coral Island is also in P. XCOM 2 is not in P. So we could write that down too. Okay, oops. So is not in P, we just draw the element sign and put a crossover. Like a slash. All right, so that's some last notation. And you can do other stuff like that too, right? You can say, all right, XCOM 2. What about the empty set? Is that in the empty set? Pause the video, figure it out. What about omega, the domain of discourse? Is XCOM 2 in or is not in both of these sets? And hopefully what you said is that, no, it's not in the empty set. Nothing's in the empty set. It's empty. And yes, of course it's in omega. It's in the domain of discourse. Everything that we're talking about is in the domain of discourse. Okay, so those are some examples. That's some notation. Again, this first video, big introduction video, lots of stuff. Future videos will be broken down a little bit more, but hopefully that's a good little introduction. If you're a little curious about some of these things like the Cantor set, set theory, different kinds of infinity, that's really fun. You can ask me about that too. We're just doing a little introduction to set theory. It's really fun. Hopefully you got it. Hopefully you're excited. I'm excited. If you have questions, let me know and have a good rest of your day. Bye-bye.